Hi, I think our video got cut before I had a chance to go over part C, so let's go over that. So this is part C of number 3. Okay. So we're still using this our given equation, so let's go ahead and plug in 0. So C1 is cosine of 0 plus C2 sine of 0. We know that sine of 0 is 0, cosine of 0 is 1, so this is C1. So we immediately find that C1 equals to 0. Okay, let's go ahead and plug in pi over 2. We have to differentiate this once, so I'm going to quickly do that at the bottom. So that's going to be 1 sine x. So that's C2 cosine x. So this is C1 sine of pi over 2 plus C2 cosine of pi over 2. Sine of pi over 2 is 1, so this is C1, and cosine of pi over 2 is 0. So this is just C1. So again, we were only able to find the value of C1, which is 0. So back into our original equation, we can write down that 0 times cosine x is always going to stay 0. So this is going to be C2 sine of x. Since we only have one constant, we can just go ahead and just write C. And so this would be our final answer for part C. Alright, and let's go over our last problem assigned, which was the problem 8, part A. Okay, so we first need to solve this second order differential equations, which we can rewrite this as r squared plus k squared equals to 0. Subtract k squared both sides, we have r squared equals to negative k squared, and putting the square roots to both sides, this gives us r equals to plus minus ki. So we have imaginary answer, in this case where our alpha is 0 and beta is k. So this would refer back to our third category of solutions. So we can write this as phi of x equals to e to the power of alpha x. So that's e to the power of 0, which is 1. And it's going to be C1 cosine of kx plus C2 sine of kx. Okay. So this is our general solution. It seems like for all of these parts, subparts, we have to utilize the differentiated once version. So we're going to go ahead and just do that quickly. That's going to be negative k C1 sine of kx plus k C2 cosine of kx. Alright, so we'll keep this around as we do the subparts of this equation. Okay, so let's go ahead and do part 1 of A. So let's plug in 0, phi. So that gives us C1 cosine of 0 plus C2 sine of 0. Okay, so we know that sine of 0 is 0 and cosine of 0 is 1, so this is C1. And that's given to us as 0, so we have found our C1 value. Let's go ahead and plug in pi. Sorry, I plugged in 0 just now, not pi. Now let's plug in pi, so we have C1 cosine of pi plus C2 sine of pi. Cosine of pi, this is negative value, so this is negative C1. Sine of pi is also 0, so that disappears, and that gives us 0. So for this case, we just know the C1. We can conclude that C1 is 0, so let's go back and plug it in. Phi of x equals to The cosine term is gone, so we have C2 sine of kx. So this is our equation. Sorry, this is our general solution. This is x. They want us to find the values of k that will allow this to have a non-trivial solution. So we can't have this equaling 0 because that's going to give us a trivial solution. So our k value can exist anything 1, 2, 3 all the way. It's just that it can't have 0, and it can't be negative because having 0 will get us to sine of 0. That's going to equal to 0. That's going to give us a trivial solution. We also cannot have negative numbers because it is defined that k is a non-negative constant. So this is our answer for part A. All right, let's go on to part B, or part 2. Okay, so this one, let's plug in 0 to our differentiated equation. So negative k c1 sine of 0 plus k c2 cosine of 0. So this part is gone because it's 0, and cosine of 0 is 1, so we have k c2 equals 2, and that's going to equal to 0. So here we can divide both sides by k and get to the solution that c2 is 0. Doing the same thing, let's plug in pi. So that's negative k c1 sine of pi plus k c2 cosine of pi. Cosine of pi, this is negative 1. Sine of pi is again another 0. So we have negative k2 c2, that also is given as 0. Here, c2 is 0. Okay, so we were only able to find an exacting answer for c2. So our general solution is going to be c1, or I don't have to write c1, there will be only one constant, cosine of kx. Okay, so the values that k can hold, first of all, it's non-negative, so I can throw out all the negative numbers. It can hold 0 because cosine of 0 does not equate to, does not give the value of 0, so I can have 0 in this case and all the other values as well. Okay, so this is the answer for part 2. All right, let's go over to part 3. So I guess the first condition is given that phi of 0 is equal to phi of pi. So let's go ahead and think about that. Phi of 0, that is going to be, sine part would be 0, so we have, and cosine of 0 is 1, so this simply gives us c1. Okay, that's easy. Let's go phi of pi. Sine part, sine of pi, it doesn't matter what k value it is. Sine of pi, sine of 2 pi, 3 pi, all of those is going to give the value of 0. So we're mainly worried about this. This is going to give us c1 of cosine k pi. And for this case, we're going to have two separate answers. One answer is that if k is odd, then we're going to get negative c1. Because if it's cosine of pi, it's negative 1. Cosine of 3 pi is negative 1, and so on. So if k is odd, and we're going to get just positive c1 value if k is even. And if you think about it, cosine of 2 pi is 1, positive 1. So it's going to be positive c1. Cosine of 4 pi is also positive 1. So we're going to have different values. We have to be careful here. Let's see. If let's say that k is odd, then we're given that these two things are equal. So if k is odd, then we have to take on that c1 equals to negative c1. This can only have one solution. k1 has to be 0. If k is even, then can take on the value of C1. We have C1 equals to C1. This can be anything. If C1 is 1, then 1 equals to 1. If C1 is 5, 5 equals to 5. So this is going to give us the non-trivial solution, while this is going to just give us just a trivial solution, but we've only talked about C1. Okay. All right, so let's keep this and go on to our second part, which says that now phi differentiated once 0 equals to phi differentiated once of pi. Okay, so let me plug in phi differentiated once equals to, so we're looking at this. Sine of 0 is always going to be 0, so I have k C2, and cosine of 0 is always going to be positive 1. Okay, so we have that figured out. Let's go over and plug in pi. So pi, sine of pi is also always going to be 0, and likewise, it doesn't really matter what k value, pi, 2 pi, 3 pi, that's always going to give this value sine as 0. And for this, I think we're going to have another two cases. So k C2 cosine of kx, and this will take, if c is odd, then we're looking at negative values. So we are going to get negative k C2 if k is odd. Okay? And again, cosine of pi, oops, sorry, that's pi. Cosine of pi is negative 1, cosine of 3 pi is negative 1, and so on. This is going to be positive k c sub 2 if k is even. Okay. And it's again, cosine of 2 pi is 1, positive 1, cosine of 4 pi is positive 1, and so on. Okay, so let's take a case where, do the same thing. If k is odd, then k C2 must equal to negative k C2. This would again get us only one possible solution. C2 has to be 0. Okay? If k is even, then we have k C2 equals to k C2. This C2 can be any value because it's, k is the same thing, so we can just kind of take that away, and that's going to allow us to have any values for C2. All right, so for this reason, because our direction says our answer must be non-trivial, we're going to have to stick with k being even for both of our cases. It was true case. So our answer is going to be that k is going to be even. A mathematical way of saying that would be k equals to 2n. Where n can take on 1 or 0, 1, 2, all of those values, or you can just say that k should be even.